Hey Steve, is there some sort of model, tool, or formula to tell me what my return on an investment should be?
Of course there is, Mike. It's called the Capital Asset Pricing Model, also known as CAPM.
Now, while the name of that sounds really scary and complicated, it's actually pretty easy and straightforward.
In this video, we'll investigate CAPM, look at the formula.
All its components, and show you guys an example.
Let's get started. So, Mike, in the words of all the college freshmen, what is CAPM?
Steve, that's a great question. CAPM is a model that can tell you what your expected return on a security or portfolio should be, considering the risk-free rate and adding a risk premium. Steve, what are the components?
Well, Mike, like you said, we have the risk-free rate, beta, and your expected market return.
Now let's go over the formula.
All right, Mike, let's jump into the formula.
Let's do it, guys. The first component is RF, which stands for the risk-free rate. Now this is going to be typically represented by a government security, like a bond. If you want to learn more about this, check out our video on interest rates. The second component is beta, which measures risk or the volatility of how the stock moves with the market. We'll go over this more in depth later. The last component, which you can see on the bottom of your screen, is RM, which stands for the expected return on the market. Now this is a number you're going to have to assume, but if it's on a test, it'll be given to you, don't worry.
Now let's take a closer look at beta. All right, Mike, now let's take a look at beta in Excel.
All right, Steve, let's get started. So the first thing we need to do in order to calculate beta is find our historical prices for both stock A and the S&P 500, which will serve as our index. Now you can find these historical prices all over the internet, but for time purposes, Steve and I already have them downloaded here. We got ours from Yahoo Finance. Now the most important thing about this is to make sure that your dates match up. For example, July 1st, 2014 here, and make sure it's the same date here. So now that we have our data points, we can find our historical monthly returns for our stock. So in order to find this, it's real simple. Set up our formula, which we have here also. It's our new price minus our past price divided by our past price. Bam, there it is. 2.8%. Now the great thing in Excel, we can drag this all the way down. And don't worry about this divide 0 that's going to come up. That just means there's no number here. Now the great thing, we can just copy this formula right over. Copy it and Control V to paste it. Drag it all the way down. And that's the majority of the work to find out beta. We're just 2 steps away and we'll be good to go. So now that we have this, which probably took more time to figure out than the length of the whole problem will, we can find first our covariance of stock A and the S&P 500. Now covariance, that sounds like a confusing word, but to do it in Excel, it's real simple. Just type equals COVAR, and you'll see covariance P, covariance S. We're going to do covariance S because that stands for sample, meaning we don't have every single monthly return forever. We only have a select sample. So we're going to copy our returns here. Go all the way down. Make sure not to include that divided by 0. Hit a comma. And then do the same thing for the S&P 500. Hit enter. Bam. There we have a decimal that doesn't mean a whole lot to us right now. So next we have to find our variance of the market. And this is just as easy. So if we type VAR, you're going to see population sample again. So we're going to use sample for consistency. Copy down our returns for the S&P 500. And hit enter. Another decimal that doesn't mean a whole lot to us. But now we only have one more step left. The final step to find beta is our covariance divided by our variance. And there it is, 0.87. Now one last thing to remember, if you can set up your spreadsheet similar to ours, it's going to be a lot less complicated to find beta because everything's nice and organized. So as you can see, our beta is 0.87, which means for every 1% the S&P 500 goes up, stock A will go up 0.87% on average. So there's beta. Let's look at an example.
Okay, Mike, now let's do an example in Excel using the beta that we just calculated.
Let's take a look, Steve. The first step is to find our risk-free rate. Now, if you're doing a test in class, it'll be given to you. If you're doing a take-home exam, you might have to calculate it. Remember, it's typically represented by a government security. So for the purposes of this example, we're going to assume our risk-free rate is 1.5%. So let's just input that value here. And we'll move on to the second step, which is our beta multiplied by our expected return on the market minus the risk-free rate. Now remember, the expected return on the market is also an assumption. So on a test, this would have to be given to you, or you'll have to assume it for yourself. And our beta we have already calculated. So for this part, it's going to be our beta multiplied by our expected return on the market. For this example, it'll be 4.75% minus our risk-free rate of 1.5%. And now we just have one more step left to add the risk-free rate to this number right here. So we have equals plus our risk-free rate, and there it is, 4.35%. Now you might ask, Steve and Mike, why is that number less than the expected return on the market of 4.75%? And that's a great question. If you remember correctly, our beta is 0.87, meaning for every 1% the S&P 500 goes up or down, our stock will go up or down 0.87% of that. So that's why it's a little bit less.